Hello friends, welcome back to our channel. So in today's session we'll see one more concept in functions in set theory. So in our previous session we have seen the introduction to functions, what exactly the function mean and how the elements will be mapped from one set to another set, as well as what is meant by a codomain, domain, image, pre-image and the range. That means all the terminologies of functions we have seen. And in today's session we'll see what are the different types of functions that can be applied on sets. So let's start the session. Types of functions. So first I'll list out all the types of functions and then we'll see one by one with an example. Okay, so the first one is one-to-one function. One-to-one function, which is also called as injective function. Injective function. And the second one, onto function, which is also called surjective function, which is also called as a surjective function. The next one, one-to-one and onto function, which is also called bijective function. Bijective function. And the next, many-to-one function. Many-to-one function. Identity function. Identity function. And finally, constant function. Constant function. So these are different types of function we can apply on sets, right? So one-to-one, onto, one-to-one and onto, many-to-one, identity and a constant. So let's see one by one. Coming to the one-to-one function. So here the name itself indicates every distinct element of set A should be mapped with a distinct element of set B. So I'll write here, every distinct, that means unique, distinct element of A which belongs to capital A must be mapped with distinct element of small b belongs to capital B. So we know that a function, the definition of a function means every element of A should have exactly one element on B. Okay, so for example, this we will represent it as function A to B, and this function is a one-to-one function. So let us take an example of this one. So take two sets. Okay, so one is A, B, and there is some sort of function applied here, and we are having A, B, C, 1, 2, 3 and 4. Let us take 3 elements in set A and 4 elements in set B. So A is mapped to 2, B is mapped to 1 and C is mapped to 4. So coming to the definition of one-to-one, every distinct element of set A must have a distinct element on B. So A is having an image 2, B is having an image 1, C is having an image 4. So A, B, C are distinct elements of A, and similarly those are mapped with the distinct elements on B. So this is called one-to-one function. One-to-one function, right? For example, let us take two sets A, B, C, 1, 2, 3. So if this is the manner, right? So this is not even a function. This is not even a function because B doesn't map with any other element. So not at all a function. Not at all a function. For example, B is also mapped to, so this is also not, it's a function because every element of A is associated with only one element on B. So A is associated with only one element 1, B is associated with only one element 3, C is associated with only one element 3. So this is a function but not on one to one. But not one to one. Okay, because every distinct element of A should have a distinct element of B. So this is a function. Yes, this is a function, but not one to one function. So this is a one to one function and also a function, right? So such type of functions we call it as a one to one or injective function. Injective function. Okay, right. The next one, onto function. Onto function. Onto function, or this is also called as surjective function. Surjective function. So here every element of B must be mapped with element of A. So every element of B should be mapped with, so here there is nothing, right? So every element of B must be mapped with element of A. So for example, let us take the same example, A, B and C. Sorry, I'll write it with a small letters. A, B and C. 1, 2, 3. A and B, which is having a function f, which is a onto. So if there is a function in this way, so every element of B is having mapping with a element of A. Okay, every element of B is having mapping with A. So this is called onto function. This is called a onto function. Okay, another example. B, C, 1 and 2. See, this is A and this is B, for example, and there is a function f. Now you can say, first check out whether it is a valid function or not. Yes, it's a valid function because every element of A is having exactly one element. Okay, so this is a valid function. Next, every distinct element of A should be mapped with a distinct element of B. That violates because A and B are mapping to the same element of B. So this is not one-to-one function. This is not one-to-one function. And every element of B must be mapped with element of A. So 1 is mapped with A, B and 2 is mapped with a C. This is onto function. This is onto function. Okay, so this is an example. This is a function but not one-to-one and onto. So there should be, if there are, so obviously we can also say that the range will be automatically B. If the range of this particular function is B, obviously we can say it is a onto function. So what we are saying, for example, if there is no mapping towards this one and only this one, what's the range of this function? We are saying only 1, 3, because there is no mapping for 2. This is a valid function, but it is not a one-to-one function. Okay, and it's also not a onto function. So now for this example, for this one, what is a range function? Range is nothing but 1 comma 2, because all the elements of B are mapped to A. That means which is nothing but B. The set B will be the range. So whenever the set B will be the range, then automatically we can say it as a onto function or a surjective function. Onto function or surjective function. Hope you understood. Right? Next, coming to the next one. The third category, one to one and onto, which is also called as bijective function. Bijective function, right? So the name itself indicates if the function is both one to one and onto, then it is called bijective function, right? So if the function satisfies both the onto and one to one, right? So example, let us take an example. So A, B and C, 1, 2 and 3, if C is mapped with 1 and A is mapped with 2 and B is mapped with 3, and coming to A, B with a function F, right? So here you can see, first let us check with the function, normal function. Yes, this is a normal function because every element of A is having some exactly one element on B. So A is having 2, B is having 3 and C is having 1 as a images. Next, one to one. Every distinct element of A should have a distinct element on B. So A is having distinct element of 2, B is having distinct element 3, C is having element 1 and on 2. So if the range of this particular function is B, then we can say it as an onto. That means every element of B should be having mapped with every element on, element on A. So the same thing. So it satisfies both one to one as well as onto function. It satisfies both one to one and onto function. So that's why this function A tends to B is bijective function. It's a bijective function because it satisfies both onto and one to one functions. So hope you understood this one, right? Yes. So we'll go on with the next category, the next type of function. So which is a many to one function, which is a many to one function. Many to one function. So the name itself indicates multiple elements of A, multiple elements of A should map with one element of B. Then we can say it as a many to one function. The name itself indicates many values of set A are mapped with a single element of set B. Example, you can take two sets A, B, C, 1, 2. Then you can go with, this is a many to one because multiple elements of A. Okay, so this is a function. This is a function F. So multiple elements of set A. Multiple elements of set A means A and B are mapping towards a single element 1 and C is mapped with a 2. So multiple paths to a single element. So such type of thing we call it as a many to one function. So it will be represented as A to B. A to B. Hope you understood. So this is not an onto function. It's an onto function. It's not a one-to-one function. So it's not a bijective, right? So the same thing we can write valid function. It's a valid function. One-to-one. It's not one-to-one, and it is onto function because all the elements of B are mapped, right? And it is not bijective. It is also not a bijective function, and it is many to one. The same function, these things. Okay, so I hope you understood this one. The next, we'll move on with the next one, which is an identity function. Identity function. If all the elements of A are having image as itself, that means all the elements are mapped with themselves, is called as a identity function. For example, let us take A, and it will be mapped with again A only. So A, B, C, and again A, B, C, which is mapped in this way. Okay, then we can call it as an identity function. So A is mapped to A, B is mapped to B, C is mapped to C. So all the elements of A are having images. So we are saying that, so this will be considered as F A to A, and this we are calling it as a domain, and this we are calling it as a codomain, and whatever the elements in this particular codomain are called as an images. So A is having an image A, B is having an image B, C is having an image C. So all the elements of A are having image as itself. It's called as an identity function. Simple thing, right? So here we have to draw the function like this. We have to represent this one. Okay, so this is the identity function. The next one, and the last one, which is a constant function. Constant function. Constant function. What is a constant function? If all the elements of A are mapping towards a single element on B, then it's called as a constant function. If all elements of A are having same image, then we can call it as a constant function. So only one image for all the elements of A. So for example, let us take A, B and C, and again we will take one more set, some 1. So this is A and this is B, and there is a function F and C. If this is in this format, okay, if it is in this format, you can see all the elements of A are having the same image, 1, or you can take it as some 5. Okay, all the elements of A are having the same image, then we can say it as a constant function. For example, this one. So is it a valid function? Yes, it is a function, valid function. Is it a one-to-one function? No, because all the 3 elements are mapping towards a single element. So it is not 1 to 1. And is it onto function? Obviously it is an onto function because only one element is there, that is also mapped to different elements. So this is onto function. And if it is not a 1 to 1 and it's onto, it is not a bijective. It is not a bijective. Is it a many to one? Obviously this is many to one because many elements are mapping towards a single object, single element of B, right? So f a to b, f a to b is a valid function and valid onto function, valid many to one function, but it's not 1 to 1 and bijective, right? So these are the different categories of functions. So we have seen 1 to 1 or injective function, and onto function or surjective function, and bijective function which satisfies both onto and 1 to 1, many to one function, identity function, and finally the constant function, right? So let's stop here, and hope you understood this one. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.